Mr. Wright here, and welcome to this film on vectors. Now, in this film, I will walk you through 16 IGCSE questions on vectors. The first 2 or 3 are sort of level 7-ish, and then the remaining questions are all top grade, sort of grade 8, grade 9, I would think. Okay, quite a lot of questions at the end where you have to find ratios and that sort of thing. Now, there's a link in the description so you can download the questions and then you can have a go at the questions before me or work alongside me. If you're just getting the hang of these methods, then you probably want to work alongside me for a question, then try a question yourself and watch me do it, and that sort of thing. I'll also put a link in the description to my vectors playlist where there are a number of how-to films if you want to revise how to find the magnitude of a vector, that sort of thing. But these questions are tough. So good luck, take your time. I imagine that to work your way through the 16 questions might take you a couple of sittings, but it will be worth the time investment because you and I both feel sure that vectors are coming up in your paper too. And very often there are questions that appears towards the end, and it's well worth getting those 5 or 6 marks because that's half a grade, and these are tough grade 9 type questions. Let me know how you get on in the comments, leave me a question if you'd like to, and of course, I'll help you out. Right, let's get on with the maths. Question 1. Right, we're given 2 vectors here. We're given the vector AB and the vector CB, and we're asked to find the magnitude of AC. So the first thing to do is to find the vector AC. Right, well, if I was going to go from A to C, then I would go from A to B, and then from B to C. Now the vector AB, I know. Now the vector BC is going to be the negative of CB, so it's going to be -1, -3. So add those together, and I get the vector 5, -12. So I'm actually being asked to find the magnitude of the vector 5, -12. So the magnitude of that vector AC is going to be the square root of 5 squared plus 12 squared, which is the square root of 169, which is 13. You might have recognized the 5, 12, 13 triangle anyway. So the magnitude of the vector AC is 13. And that's question 1 done. Question 2. Right, we've got 2 irregular hexagons, each centered on that point 0. And we know that the larger one is an enlargement of the smaller one with a scale factor of 2. So the dimensions of the larger one are going to be twice the dimensions of the smaller one. Right, I'm told that OA is A, well that's marked on the diagram, and also that OB is B, which is also marked on the diagram. Right, write the following vectors in terms of A and B, simplify your answers. Now AB, well to get from A to B, I'm going to go A to O, because I know that vector, and then O to B, because I know that vector. A to O is -A, plus O to B is plus B. So my answer is going to be B minus A. Okay, now K to I. Where is K? And there's I. So to go from K to I, I'm going to go from K to J, and then from J to I. So I'm going to say that K to I is K to J plus J to I. Now K to J. Well, K to J is just twice that vector, isn't it? Twice AB. So K to J is twice A to B. And J to I is going to be twice that vector there, twice AB. Okay, so that is going to be twice AB, twice B minus A, plus twice AB, twice b. So that works out to be 4b minus 2a. Okay, now L to D. Let's clear off this little lot. Right, from L to D. Okay, well, there are lots of different ways of doing this. I'm going to go from L to F, because that's like AB. Then I'm going to go from F to O, because that's like AB again. And then I'm going to go from O to D, because that's a minus A, isn't it? So my LD is going to be from L to F, from F to O, and from O to D. So my L to F is the same as AB. My F to O is the same as AB. And my O to D is like a negative OA, or AO. So that's going to be B minus A plus B minus A minus an A. So altogether, 2B minus 3A. Those are my answers for those first three questions there. Now, part B. The triangle OAB has an area of 5 square centimetres. Let's just have a quick look at which triangle that is. Get rid of my working for the last question. So OAB, that's this triangle here. So that has an area of 5, and I need to calculate the area of the shaded region. Right, well, if that small triangle has an area of 5, then the area of the small hexagon, that hexagon in white in the middle, is going to be 6 times 5, because it's small hexagon made up of 6 of those equilateral triangles, so the area of the small hexagon is 30. Okay, now I'm asked to find the shaded area. So I'd really quite like to know the area of this whole hexagon, because then I can subtract away the area of the small hexagon. Now that area of that large hexagon. Right, well, if you remember, the large hexagon is an enlargement of the small one with a scale factor of 2. Well, if its dimensions are twice as long, its area will be 4 times as large, 2 squared times as large. So the area of the blue hexagon is 120. So therefore, the area of the shaded shape is going to be 120, the large hexagon, minus 30, the area of the small hexagon, leaves me with an answer of 90 square centimetres for the area of the shaded region. And that is question 2 complete. Question 3. Right, here are 2 vectors. I've been given the vector BA and the vector BC. I have to find AC as a column vector. So I've got to go from A to C. Right, well, AC, let's have a look. Well, I could use this vector, couldn't I, to go from A to B. So I could do the vector A to B and then go from B to C. And that will mean that altogether I've gone from A to C. So let's have a look. Well, A to B, I've got BA there. So I will simply find the negative of BA, which will give me AB. And then onto that, I've got to add BC. Well, BC is 9, 1. So I'm going to have 5 minus 4. And onto that, I have to add the vector 9, 1. So altogether, I'm going to have 14, 3. And that is my vector. Sorry, that's a rather foolish mistake. 14 minus 3. And that is going to be my vector AC. 14 minus 3. And just to be very clear, I've added the 5 and the 9 to get the 14. And I added the minus 4 and the 1 to get minus 3. To give me an answer of 14 minus 3. Question 4. Now, in question 4, tells me that the diagram shows a parallelogram A, B, C, D. Yes, I can see that. Gives me a couple of vectors here, look. It tells me A to B and A to C. And I'm also given the coordinates of the point B. So that point B has coordinates of 5, 8. Work out the coordinates of the point C. Right, well, there are lots of ways to do this, but given that I've got the point B, I'm going to work out the vector BC, work out what the movement is from B to C, and then I can apply that movement onto my coordinates for B. So how am I going to work out BC? Well, I know AB, look, and I know AC. So to go from B to C, I could do negative an AB, i.e. go from B to A, and then add on A to C. And then my complete movement would have been from B to A to C, from B to C. So minus AB is going to be minus 2, 7. That's what BA is, and add on to that from A to C. Okay, well that's going to give me minus 2 and 10 is 8, and minus 7 and 11 is 4. So the vector B to C, the movement from B to C is 8 in the x direction and 4 in the y direction. So if B has these coordinates, and then I go to C, I need to add on a horizontal movement of 8 and a vertical movement of 4. So C is clearly going to be 5 plus the 8 is 13, x coordinate of 13, and a y coordinate of 8 plus 4 is 12. So C is going to be the point 13, 12. Right, part B. The point E has these coordinates. E has the coordinates 63, 211. Use a vector method to prove that ABE is a straight line. Well, what I'm going to do here is I'm going to get the vector AB, and I'm going to compare it to the vector BE. And I'm going to show you that one of those vectors is a multiple of the other, because that will show you that if A to B, say, is this movement, and if B to E is a multiple of that, then it's going to look something like that. And A to B to E will be a straight line. If B to E wasn't a multiple of A to B, then B to E would be off in a different direction, and ABE would not be a straight line. So the vector AB, I've already got that. It's 2, 7. So all I've got to do is to find the vector BE. Now from B to E, well, B, I already know, it's got coordinates of 5, 8. And E, I already know, has got coordinates of 63, 211. So to go from B to E, my x-coordinate has gone from 5 to 63, so that was a horizontal movement of 58. And my y-coordinate's gone from 8 to 211, so that's a vertical movement of 203. So that's the vector BE. Now I've just got to show that BE is a multiple of AB. Let's have a look. 58 divided by 2 is 29. Now is 203 divided by 7 also 29? Yes, it is. So BE is 29 times AB. Meaning that ABE is a straight line. And that is question 4 complete. Question 5. Right, in question 5 I've got a triangle ABD, and I'm told that N is the midpoint of BC. So I'm just going to write a little half and half just to remind me that N cuts the line BC in half. I'm told that C is the midpoint of AD, so I'm just going to write a little half and half there. And I'm told here that M is the point on AB, so that A to M to B is 3 to 1. Right, that means that the line from A to B has been cut into 4 pieces. 3/4 of it here and 1/4 of it there. Right, so I have written these pieces of information on the diagram now. A to B is a vector of Q. A to B is a vector, of P. And A to C is a vector Q. It's always worth taking your time to put the information on the diagram. Right, part A. Express in terms of P and Q the vector BD. Let's have a look, BD. From B to D. But if I was going from B to D, I'm just looking at what I know, I would probably go from B to A, and then from A to C, and then from C to D. So let's write that down. I said I was going to go from B to A, and then from A to C, and then from C to D. That's my route. So B to A is minus a P, A to C is a Q, and then another Q. So I'm going to end up with 2Q minus P, and that is my vector B to D. Good. Next, M to N. M, start on M, here's M, and I've got to finish up at N. Lots of different ways of doing this. I'm going to go from M to A, and then from A to C, and then from C to N. Okay, so let's just write down that route here so that I don't forget it. I said I was going to go from M to A, and then from A to C, and then from C to N. Okay, now M to A I know already. That is minus 3/4 of P. A to C, I know that's a Q. Now C to N. C to N is a half of C to B, isn't it? So I better work out C to B. I'm going to go up here and work out C to B. C to B. So C to B will be minus a Q, going from C to A, and then plus a P. So C to B is P minus Q. So now I'm going to come back down here and substitute that in here. So I'm going to have minus 3/4 P plus Q plus a half of C to B, which I've just worked out to be P minus Q. So that is what I'm simplifying. Right, so we're running out of room here. I'm going to zoom up. So that's going to be minus 3/4 of P plus Q plus half a P minus half a Q, which is, if I look at the P's, I've got plus half a P there. Oh no, I haven't. I've got minus 3/4 plus a half. So I've got minus 1/4 of a P, and then Q minus half a Q gives me plus half Q. So that is my simplified expression for MN. Minus 1/4 P plus a half Q. And meanwhile, my answer for BD, write it on here, 2Q minus P. Okay, right, so about that route I don't need anymore. Part B, state, giving reasons, 2 different geometric facts relating MN and BD. Right. Well, here is MN and BD. They're my previous two answers, aren't they? MN is minus a quarter P plus a half Q, and BD is 2Q minus P. I'm going to write those the other way around so I can compare them more easily. Minus P plus 2Q. Now, if I have a look at this line and this line, I see that my coefficients in BD are 4 times the coefficients of MN. So BD equals 4 times MN. So I can get two geometric facts from that. Number one, MN and BD are parallel, and BD is 4 times as long as MN has 4 times the magnitude. So there are my two geometrical facts. And that is question 5 complete. Question 6. Okay, OAB is a triangle. And now I'm given a couple of vectors, and I'm given some facts about a point C and a point D. Using a vector method, prove that ABDC is a trapezium. Right, this is crying out for draw a diagram. So I'm going to draw a diagram now of a triangle. So here's my triangle. Okay, now my triangle is going to have O, A, and B. Right, OAB is a triangle. Good. OA is a vector of A. Let's stick that on. It is always worth taking your time to understand the question, and in this case that involves drawing a diagram, labelling it with its vectors here. Now there's more information still. The point C lies on OA, so that O to C to A is 1 to 2, so that's going to be C there. That's going to be a third of the way along, and that's going to be 2/3 of OA. Meanwhile, D lies on OB in the ratio 1 to 2 again, so that's going to be a third, and that's going to be 2/3 of OB. So I've put all the information on the diagram now. Using a vector method, prove that ABDC is a trapezium. ABDC, that is a trapezium. Well, it's going to be a trapezium if AB and CD are parallel, isn't it? If those two lines are parallel, then I'm looking at a trapezium. So really, this is just a question of, can you prove those two lines are parallel? And it says use a vector method, so we're going to find the vector from A to B and the vector from C to D, and we're going to see if one of them is a multiple of the other. Let's have a look. So the vector from A to B. Right, let's get rid of this fluorescent line now, and let's concentrate on the vector from A to B. That movement there, from A to B. Right. Well, if I was going to go from A to B, I think I would go from A to O, and then from O to B. A to O is minus A, O to B is B, so I get B minus A. That's my vector from A to B. Right, okay. What about the vector from C to D? That's this one, from C to D. Right, if I was going to go from C to D, then I think I would go from C to O, and then from O to D. Now C to O is a third of A to O, and A to O is minus A, so I get minus a third of A plus, now O to D is a third of O to B, so it's going to be a third of B. Right, let's have a look. Those are my two vectors, A, B, and C, D. Well, let me write this one round so it's got the A plus the B. And now I can compare my coefficients, can't I? Remember there's a 1 here, 1A and 1B. And look at that. -1, minus a third, and 1 and a third. CD is a third of AB, isn't it? But you've got the A's and B's in the same ratio there. So AB equals 3 times CD, which implies that AB is parallel to CD, which implies that ABDC is a trapezium. And there is my answer for question 6. Question 7. Right, the diagram shows a triangle ABC where A, B, and C represent the position of 3 towns. Okay. I'm given a vector, look here, and a vector here. Prue travels directly from A to B and then directly from B to C. Okay. Yang travels directly from A to C. Given that the values for A, B, and BC are in kilometers, work out how much further Prue travels than Yang. So I've got to work out Prue's distance and then Yang's distance. Give your answer in kilometers, correct to 1 decimal place. Right, let's have a look. Let's do Prue first of all. Now Prue is going to go from A to B and then B to C. Right, let's have a look at that then. So from A to B, well, that's the vector 7 minus 2, isn't it? And then from B to C, well, that's the vector minus 3, 5. So the distance is there. Well, the magnitude of that first vector is the square root of 7 squared plus 2 squared. And then she's going to travel the distance from B to C, and the magnitude of that vector is the square root of 9 plus 25. So her overall distance then is the square root of 53 plus the square root of 34. Right, a bit of calculator use, and I get 3.111 and so on kilometers. So that is how far Prue travels. Now, what about Yang? Let's do Yang. Now, Yang just travels direct from A to C. We better find out what the vector from A to C is, haven't we? Well, the vector A to C is going to be the vector A to B plus the vector B to C. So that's going to be 7 minus 2 plus minus 3, 5. If I add those vectors up, I get 4, 3. So what's Yang's distance? Well, Yang's distance is going to be the magnitude of that vector. The square root of 4 squared plus 3 squared. Well, I recognise that as being 5 because it's a 3, 4, 5 triangle, but of course you can always work it out. So that's Yang's distance. Now, the question. How much further Prue travels than Yang? Well, Prue travelled 13.111 and Yang travels 5. So Prue has travelled 5.111 kilometres further. And it asked me to give the answer correct to 1 decimal place, 5.1 kilometres. 5.1. And that is question 7 sorted. Question 8. Right. I'm told that OMA, ONB, MPB, and NPA are straight lines, and all those are drawn as straight on the diagram. I'm told that M is the midpoint of OA, so I'm just going to write half and a half here. I'm told that ON to NB is in the ratio 1 to 5. So that means that O to N is a sixth of that line, and N to B is 5/6. I'm told that OM is A, well that's already marked on the diagram, and ON is B, and that's marked on the diagram. Okay, find in terms of A and B the vector A to N. Right, well if I was going from A to N, how would I do that? Well, I think I'd probably go from A to O and then O to N. Let's write that down. I'd go from A to O and then from O to N. Now A to O, that's minus 2A, and then O to N is simply a B. So if I wanted to write that as B minus 2A, then of course I could. And that is part A done. Okay, I'm going to go on to part B now. Let's just delete that. Let's have a look at part B. Use a vector method to find the ratio AP to PN. All right, this is the first vector method question we've covered. I'm just going to delete all this and show you how to go about this question. Now, we have to find the ratio of AP to PN. Now, what do we know about P? We know that P lies on the line AN. Okay? And we don't know where, though. And we also know that P lies on the line MB, but we don't know where. So we're going to use both of those conditions separately to start with. So you'll remember that we said that that P lies on the line AN. Okay, well in that case, AP is a fraction of the way along AN. I'm going to call that lambda. I don't know what that fraction is. I don't know how far along AN P is, but it's lambda of the way along. Maybe it's half the way along, maybe it's 2/3 of the way along. I don't know. And I'm going to use this in a moment to find the vector from O to P. Right. Now I'm going to cut my page in half. And now I'm going to use the fact that P lies on the line MB. I'm going to use the fact that P lies along this line. Again, I don't know how far along, so I'm going to say that MP is a certain fraction of the way along MB. I don't know how far, so let's just call it mu. Mu could be a third. Looking at that, maybe P is a third of the way along from M to B. A bit less than that by the look of it. But again, I don't know what that fraction is, so I'm going to call it mu. And I'm going to use this to write another expression for the vector from O to P. All right, so I'm going to work in green and work in blue. Right, let's use my green first. Here I've written that AP is lambda AN. So let's delete that. Let's go green. And I'm working, remember, with AP being part of the way along AN. So I'm going to go from O to P using that AN line, using my green route. So what I'm going to do is I'm going to go from O to A and then from A to P. Now O to A is 2A and A to P is a fraction, lambda of AN. And I've already found AN in part 1, didn't I? B minus 2A. So now I'm just simply going to simplify that. 2A plus lambda B minus 2 lambda A. Let's put those A's together. 2A minus 2 lambda A plus lambda B. Now, in a moment, because I know I'm going to use the coefficient of A and the coefficient of B, I'm going to wish I had pulled out my A here and lambda B. So I'm going to write that expression in that form because here I can see I've got the coefficient of A and I've got the coefficient of B, and that's going to be useful in a minute. Right, back to the blue route. Now, the blue route is all about P being a fraction of the way along from M to B. It's all about this route here. and p is some fraction of the way along that line, mu of the way along. And I'm going to use that to write the vector OP. So this time, the route I'm going to take is I'm going to go up to m, O to m, and then I'm going to go from m to p. So I'm approaching p via my different route, my different straight line, via the straight line MP. Now, OM is simply A, and MP is going to be a fraction of MB. Right, so that's going to be A plus mu. Now, what is MB? MB is minus an A plus 6B. So that gives me A minus mu A plus 6 mu B, which gives me A, I'm going to use this coefficient, so I'm going to write it as A lots of m minus A plus 6 mu B. And here I've got my coefficient of A and my coefficient of B. Right, what on earth am I going to do next, you might wonder? Well, I've got two expressions there for OP. I've got my green expression and my blue expression, but they're both equal to OP. Now, if both of those expressions are equal, that means that the coefficients of the A's must be equal and the coefficients of the B's must be equal. And that fact is going to allow me to write a pair of simultaneous equations because I know the coefficients of the A's, those two expressions, must be equal. So I know that 2 minus 2 lambda must be equal to 1 minus mu. And I know the coefficients of the B's must also be equal. So I know that lambda equals 6 mu. So now I've got a pair of simultaneous equations with just lambda and mu. So I can use those two simultaneous equations to find lambda and find mu. Now it's just a question of how you want to do that. You can do it in many different ways. I've given an expression here for lambda, it's 6 mu. So I'm going to rewrite the top equation, but instead of lambda, I'm going to use 6 mu. So it's 2 minus 2 lambda, that'll be 12 mu, equals 1 minus mu. Add 12 mu to both sides, gives me 2 equals 1 plus 11 mu. So 11 mu equals 1, so mu is 1/11. And lambda, you remember that was 6 mu, so lambda will be 6/11. Okay, now let's just go back to the question. It wants me to find the ratio of AP to PN. Now, here I've written that AP equals lambda AN, and now I know what lambda is. So I know that AP is 6/11 of the way along AN. Well, that means that the vector of AP to PN, if P is a 6/11 of the way along, the vector must be 6 to 5. So that is my vector from AP to PN. And that is our first example of using this vector method to find ratios. And we've got a few questions like this coming up. We always follow a similar method. So stick with me. You'll get the hang of it if you haven't already. If you think you're on top of it, maybe try the next question and then watch my solution. If you'd like to, of course, you can work alongside me as I do question 9 and see if that helps you get the idea. Right. But anyway, that is question 8 complete. Question 9. Right. We've got a triangle OAB. Yep, that's in the diagram. And we're told some vectors. So let's mark those on the diagram. We're told the vector from O to A is 8A. And we're told the vector from O to B is 6B. Okay, M is the point on OB such that OM to MB is 1 to 2, so that's a third, and that's 2/3. N is the midpoint of AB, so that's a half, and that's a half. And P is the point of intersection on ON and AN. Okay. Using a vector method, find OP. It's a simplified expression. Show you're working clearly. Right, we've got P is a point which lies on two lines, so we're going to use that sort of system again. Okay, let's start off in the knowledge that P lies on the line ON. Now, I don't know how far along that line it is, of course. Looks like it's about half, but I wouldn't like to guess. So I'm going to say that OP is a certain fraction of the way along ON. I'm going to say it's a mu of the way along ON. Mu is a fraction. Okay, so that's going to be my green method there. I'm going to follow through that in a moment. Now, I'm also going to use the fact that P lies on the line MA as well, because P also lies on this line, but I don't know how far along. So I'm going to say that MP is a certain fraction of the way along MA. I don't know how far. I'm going to call it lambda of the way along MA, where lambda is a fraction. I don't know how far along P is, so I'm going to say it's lambda of the way along. And I'm going to use this blue fact to also construct a vector for OP. So that vector is going to be OP going from O to M and then M to P. O to M and then M to P. Let's continue on this blue line, see what we get, shall we? Now, O to M is simply a third of 6b. Now, M to P is lambda of MA, some certain fraction of MA. I've got to find MA then, haven't I? Okay, well, so I've got a third of 6b, that's 2b, plus lambda of MA. How shall I find M to A? Let's have a look. M to A. Well, I think if I was going from M to A, I'm going to go from M to O and then from O to A. So I can do that. It's going to give me 2b plus lambda. M to O is minus 2b, and O to A is simply 8a. 2b plus minus 2 lambda b plus 8 lambda a. Okay, so that is 2b minus 2 lambda b plus 8 lambda a. Now in a minute I know I'm going to want the coefficient of the b, so I'm going to write that as b lots of 2 minus 2 lambda equals, plus 8 lambda a. Good, that's my expression for OP taking the blue route. Now I'm going to go back to my green route, and I'm going to continue with the fact that OP is a certain fraction, mu, of ON. Now, O to N, O to N, oh, well, that's just going to be O to B plus a half of B to A, but you could do it in another way as well. So that is mu. Now, O to B is 6B plus a half of B to A. Now, BA is going to be minus 6B plus 8A. So I've got mu times by 6b minus 3b plus 4a. So I've got mu multiplied by 3b plus 4a. So I've got 3 mu b plus 4 mu a. Now I've got two expressions here, green and blue, for the same vector. Okay, one of them took the green route and one of them took the blue route, but nonetheless I've ended up with two expressions for the same vector. Now, if it's the same vector, they're both equal OP, then the coefficients on the B's must be equal to each other, and the coefficients on the A's must be equal to each other. So I can write a pair of simultaneous equations now. I can say that 3 mu, the coefficient of B on the left, must be equal to 2 minus 2 lambda, the coefficient of b on the right. Sorry, I just had a little glitch there. Let's just go backwards a bit. So we've got 3 mu, the coefficient of b on the left, equaling 2 minus 2 lambda, the coefficient of b on the right. And we've also got 4 mu, the coefficient of b on the left, equaling 8 lambda, the coefficient of b on the coefficient of a on the right. So here are two simultaneous equations, so I can solve them to find out lambda and mu. I'm going to use this one to tell me that mu equals 2 lambda. And now I'm going to substitute 2 lambda into the top equation. So instead of 3 mu, I'm going to have 3 times 2 lambda equals 2 minus 2 lambda. So that's 6 lambda equals 2 minus 2 lambda. So that's 8 lambda equals 2. Lambda equals 2 over 8, or a quarter. And you'll remember that mu is twice lambda, so mu must be a half. Now, what's the question say? Find OP. Well, I can substitute my values for lambda and mu into either this one or this one. They're both OP, aren't they? I'm going to substitute into the left-hand one. So OP is equal to 3 mu b plus 4 mu a. So mu's a half, so that's going to be 3 halves b plus 4 times a half is 2, isn't it? 2a. And there is my answer. That's my OP as a simplified expression in terms of a and b. So OP is 3 over 2b plus 2a. And that is number 9 done. Question 10. Right. OACB is a quadrilateral. Yes, it is. And it tells me that OA is 3a, that's marked on the diagram. OB is 4b, marked on the diagram. And BC is 2a minus 2b, marked on the diagram. Part A, find the vector OC in terms of A and B. Simplify your answer. Right. OC. Well, OC, to go from O to C, I think I'm going to go from O to B, from B to C. So I'm going to say that that is equal to O to B plus B to C. So that's going to be 4B plus 2A minus 2B. So simplified, I get 2B plus 2A. Okay. Part 2. Find the vector A to B. Right. Well, if I was going from A to B, I think I'd go from A to O and then O to B. So AB is going to be A to O plus O to B. A to O is minus 3A plus O to B is 4B. So my answer is minus 3A plus 4B for part 2, and for part 1 there I had 2B plus 2A. 10b. Now, in 10b, I'm told that the point P lies on AB and on OC. Here it is, look, the point P. And I know it lies upon OC, and I know it lies upon AB. Okay, I just don't know how far along each of those lines the point P is. Let's start off with the fact that the point P lies along OC. I don't know how far along it is, but so I'm going to say in blue here that OP is a certain fraction of the way along OC. I'm going to say it's a mu of the way along OC. And I'm going to use that to construct a vector for OP. Let's do that now. OP is mu of OC, and I know from above that OC is 2b plus 2a. So I get 2 mu b plus 2 mu a. There's a formula for the vector OP based upon the fact that P is on the line OC, on this blue line here. Right, now let's begin again, and let's find a formula for the vector OP based upon the fact that P lies on this line, the line AB. So I'm going to do this up here so I can see the diagram at the same time. So I'm going to use the fact that AP is a certain fraction of the way along AB, lambda of the way along AB. Right, so I'm going to use that to construct a formula for the vector OP. So OP would have to be OA plus AP, which is OA, which is 3A plus lambda AB, which is 3A plus lambda times, now I know what AB is because I found it earlier on in the question, minus 3A plus 4B. So that is 3A plus, minus 3 lambda A plus 4 lambda B. Okay, now I know I'm going to need the coefficient of A, so I'll factorise that now. Plus 4 lambda B. So I've got a second expression for OP now. If you look on the screen there, I've got a blue expression for OP, bottom left, and a green expression for OP on the top, on the right-hand side. The expression for OP on the right-hand side came from the fact that P is on the line AB, and the expression for OP, bottom left, came from the fact that P lies on the line OC. But either way, they're two different expressions for the same vector. So the coefficients of the B's must be equal to each other, and the coefficients of the A's must be equal to each other. So I can use that fact to write a pair of simultaneous equations. 2 mu equals 4 lambda, and 2 mu equals 3 minus 3 lambda. Now you can solve those equations whichever way you like. I'm going to put the two right-hand sides equal to each other because they both equal 2 mu. So I'm going to say that 4 lambda equals 3 minus 3 lambda. 7 lambda equals 3. Lambda equals 3 over 7. Okay, and that means that mu is going to be 6 over 7. Okay, good. Right, now what's the question? Using a vector method, find the ratio AP to PB. Right. Now, I said that AP was equal to lambda AB, didn't I? So AP must be equal to 3/7 of AB. So what's the ratio of AP to PB? It must be 3/4. And that is a very hard fought 5 marks there for question 10. But I suppose it was a question 22 on a paper, so we are dealing here with the very later questions on the paper. So they're supposed to be tough. That's question 10 done. Question 11. Right, the diagram shows triangle OAB. Yes, it does, with OA extended to E. Okay. OA is the vector A. Let's mark that on the diagram. And OB is the vector B. Okay. M is the point on OB such that OM to MB is 4/1. So that must be 4/5 there. And that must be 1/5. N is the point on AB such that AN to NB is 3/2. So that must be 3/5. And that must be 2/5. OA to AE is 5/3. Right, so that's 5/8. And that's 3/8. Okay, I've done all of this information. I'll put it all on the diagram. Find an expression for ON. Okay. Right. O to N. Let's have a look. Well, if I was going from O to N, I think I'd go O to A and then A to N. So ON, O to A plus A to N. Okay, well, that's going to be, well, O to A is easy. And then I'm going to want to find A to N, aren't I? Well, O to A. Now A to N, that's going to be 3/5 of A to B. So I'm beginning to wish I knew what AB was. So I think I'm just going to take a minute to find AB. So AB is going to be A to B is minus A plus B. Great. So now I'm going to go back here to back to my formula for ON. So ON is OA, which is A, plus 3/5 of AB, 3/5 of B minus A. Swap those two around. So that's going to give me A plus 3/5 of B minus 3/5 of A. So that is going to be 3/5 of B plus 2/5 of A. Good. And that is my answer for part A. That is ON found. Okay, part B. Use a vector method to show that MNE is a straight line. Right, I'm going to work up here because then I can still see the diagram. So part B. I've got to show that MNE is a straight line. So what I'm going to do is I'm going to get the vector for MN and I'm going to get the vector for NE and I'm going to compare the two and I'm going to hope that one of them is a multiple of the other. They both got an n in common, and then if one vector is a multiple of the other, then both of the vectors are, form a straight line, don't they? M to N to E. So M to N is MO, M to O plus O to N. Okay, well that M to O is minus 4/5 of B, isn't it? Plus O to N. Oh, I found O to N in part A, look. 3/5 of B plus 2/5 of A. So what does that give me altogether? That gives me minus 1/5 of B plus 2/5 of A. Right, so that's MN done. So now I'm going to do N to E. Right, if I was going from N to E, what would I do? Oh, I think I'd just go N to A and then A to E. Right, N to A is 3/5 of B to A. Worry about that in a minute. And then A to E. Well, A to E is, A to O is an A, and that's 5/8 of the way. So I'm going to take OA, divide it by 5, and times it by 3 to give me the vector from A to E. Right, 3/5 of B to A is 3/5 of A minus B plus OA is an A, isn't it? So that's A over 5 times by 3. Okay, let's crack on. 3/5 of A minus 3/5 of B plus 3/5 of A. Okay, 6/5 of A sorry, that should have said 3/5 of A, shouldn't it? So that's 6/5 of A minus 3/5 of B. Okay, right. So I have got my two vectors here. I've got M to N, which was minus 1/5 of B plus 2/5 of A. And I have got N to E, which is minus 3/5 of B plus 6/5 of A. Now, if I can compare those coefficients, compare that and that, and compare that and that, I see that NE is 3 times MN. Therefore, MNE is a straight line. And that is question 11 done. Question 12. Right, I've got a triangle, OAB. Now I'm told what OA is, so I'm going to mark that on the diagram. O to A is a vector of 2A, and O to B is 2B. M is the midpoint of AB, so I'm going to write a half and a half. N is the point on OB such that ON to NB is 2 to 1, so that's 2/3 and 1/3. Right, that's marked, that's marked, that's marked, that's marked. P is on AN such that OPM is a straight line. So we know that P lies on the line OM, and we also know that it lies on the line AN. Now we're asked to find the ratio of OP to PM. So what I'm going to do is I am going to use the fact that P lies on the line OM first to get an expression for OP, and then I'm going to use the fact that P lies on the line AN to get an expression for OP. So first of all, in blue, let's use the fact that P lies on the line OM. So OP, of course, I don't know how far away along that line it is, P, do I? So I'm going to assume it's a certain fraction mu of the way along OM. And now I'm going to use this fact to get an expression for OP. So OP is equal to mu of OM. Right, to go from O to M, I'm going to go from O to A, and then halfway from A to B. So that is going to be O to A is 2A plus a half of A to B. A to B is minus 2A, that gets me back to O, plus 2B. Okay, let's keep on simplifying this. Mu, that's going to be 2A minus A plus B, which is mu times by A plus B, which is mu A plus mu B. Right, there's an expression for OP based upon the fact that P lies on the line, which I'm colouring in blue here, lies on the line OM. Now I'm going to get an expression for OP based upon the fact that P lies on this line, on the line AN. I'm going to assume that AP is lambda of AN, i.e. that P lies lambda of the way along the line AN. Lambda's a fraction. So now I'm going to construct an expression for OP using the fact that P lies on AN. So this time I'm going to go from O to A and then from A to P. O to A, well that's 2A. A to P is lambda of AN. Right, so I'm just going to work out what AN is now. Right, so that's going to be 2A plus lambda of, now A to N. A to N, if I was going A to N, I think I'd go A to O, and then I'd go O to N. So that's going to be 2A times lambda plus, right, A to O is minus 2A, isn't it? Plus O to N, well that's 2/3 of 2B. Okay, 2a plus lambda minus 2a plus 4/3 b, 2a minus 2 lambda a plus 4/3 lambda b. Now I know I'm going to need the coefficient of the a, so I'll factorise here, pull the a out, 4/3 lambda b. Right, now I've got two expressions for the vector OP. One expression based upon the fact that based on the fact that P lies on OM, and another expression based upon the fact that P lies on AM. And since both of those expressions are expressions for OP, I know they must be equal. So I know that the coefficients of A must be the same, and the coefficients of the B must be the same. So that's going to enable me to write a pair of simultaneous equations. One from the coefficients of A being the same, and one from the coefficients of B being the same. So now, all I need to do is to solve those two equations simultaneously. And I've got two expressions for mu there, so I might as well say that 2 minus 2 lambda equals 4/3 lambda, multiplying by 3, 6 minus 6 lambda equals 4 lambda, plus 6 lambda to both sides, 10 lambda equals 6, lambda equals 6/10, or 3/5. And I know that mu is equal to 4/3 of that. So if lambda is equal to 3/5, mu is equal to 4/5. So now I've found mu and lambda. Now let's look at the question. Use the vector method to find the ratio of OP to PM. Well, at the beginning, here in blue, top left, I said that OP equals mu OM. And now I know that mu is 4/5. So OP is 4/5 of OM. So that means that the ratio of OP to PM must be 4:1. And that is question 12 sorted. Question 13. Right, ABC is a triangle. The midpoint of BC is M, so I can write a half and a half. P is a point on AM, yes it is. AB is 4A, that's marked on the diagram. AC is 2B, that's marked on the diagram. A to P, that's not marked on the diagram. A to P is 3/2 of A plus 3/4 of B. Okay. Find the ratio AP to PM. I've got to find the ratio of AP to PM. Now I've been given AP already, look. So I'm just going to try and find PM, I think, to start with. Okay. Now, how am I going to find PM? I tell you what, it might be easier to find AM instead. So let's find AM, the whole of the distance from here to here. Okay, so AM is going to be A to C plus C to M, which is going to be A to C. Now C to M is a half of C to B. Okay, now A to C, well that's 2B, plus a half of C to B. Well, C to B is minus 2B, that gets me from C to A, and then plus 4A. So I'm going to have 2B minus B plus 2A. So that's simply B plus 2A. So A to M is B plus 2A, or 2A plus B. Good. Right. Now, I can see now that A to M, let's say I compare that with AP. A to M. So what I've got is I've got A to M, all of that distance, A to M, A to M is 2A plus B, and A to P, which is somewhere on the way, isn't it, is 3/2 of A plus 3/4 B. Look, it's 3/4 of the way along, isn't it? Because each of those coefficients for AP are 3/4 of the coefficients for AM. So AP is 3/4 of the way along, isn't it? Okay, so that means that the ratio AP to PM must be 3 to 1. So that is my solution, 3 to 1. And that is the end of question 13. Question 14. Right, I've got a quadrilateral OAED. Yes, I have. Right, I'm given some information here. Let's check it's on the diagram. I'm given the fact that OA is 2A, that's on the diagram. OB is 2B, that's on the diagram. DE is 7A plus 3B, that's on the diagram. AB to BD is 1 to 2, right. So AB, this length here, is 1/3, and this length is 2/3. Okay, all right. The point C is on AB such that OCE is a straight line. OCE, there we go. So we've got a point C, look, and it lies on two straight lines, doesn't it? It lies on OE, and it also lies on AD. Okay, brilliant. So we're going to do our usual trick, and we're going to write two expressions for the same vector. We're going to write two expressions for the vector OC. Right. Let's first of all bear in mind that OC is a fraction of the way, let's say mu of the way, along OE. I'm using the fact that C is on the line OE, but I don't know how far along it is. Okay, and that's going to enable me to write an expression for OC. I'm also, in a moment, going to use the fact that C lies on AD. So AC is a certain fraction of the way along AD, let's say lambda AD. And I'm going to use that fact to write a different expression for the vector OC. And then I'll have two vectors which are equal to each other. Right, back to the blue. OC is mu of OE. Right. Well, in that case, OC is mu times, now how shall I go from O to E? I'm going to go from O to B, then I'm going to go from B along to D, and then I'm going to go from D to E. I'm sure there are different ways, but that's how I'm doing it. So OC for me is mu times, right, OB, O to B, to B, plus B to D. Well, B to D is 2/3 of AD. I'm not sure what that is yet. Plus D to E. Well, D to E is 7A plus 3B. Okay. Now I'm feeling as if I need to find out what AD is before I can carry on. So I'm just going to quickly here, making it clear what I'm doing, find AD. Now, AD is 3 times AB, isn't it? So what is AB? Well, AB is minus 2A, that's A to O, plus 2B. So that is minus 6A plus 6B. So that's what AD is. 6B minus 6A. So now I'm going to go back to here. I've got OC equals mu times 2B plus 2/3 of AD. So that's going to be 4B minus 4A. Plus 7A plus 3B. Right. Mu. Right, let's simplify this now, shall we? So I've got 2b's, 6b's, 9b, plus the a's. Minus 4 plus 7 is 3a. So OC is 9 mu b plus 3 mu a. Okay, there's my expression for OC from my blue route. Now let's go to the green route. Right. So I was going to find an expression for O to C involving AD. So I'm just going to go from O to A and then from A to C, which is going to be 2A plus lambda of A to C, A to D, which is 2A plus, now lambda A to D. Well, what is A to D? Oh, I've worked it out here, look. 6B minus 6A. 2A plus 6 lambda B minus 6 lambda A. Right, 2A minus 6 lambda A plus 6 lambda B. Right, let's pull out the A. So I've got a coefficient for A plus 6 lambda B. Okay, I have got two expressions of the same vector. So I know they're equal. So I know the coefficients on the B's will be equal to each other, and I know the coefficients on the A's will be equal to each other. So I can write a pair of simultaneous equations involving mu and lambda. Looking at the coefficients of the B's, I've got 9 mu, that's going to have to equal 6 lambda. I'm looking at the coefficients on the A's, I'm going to have 3 mu, and that must equal 2 minus 6 lambda. So I can solve these simultaneous equations in all sorts of ways. I am going to use this equation here, and I'm going to divide it by 3. So 3 mu will equal 2 lambda. And now I'm going to, so now I've got 3 mu is 2 lambda, and I've got 3 mu is 2 minus 6 lambda. So 2 minus 6 lambda must equal 2 lambda. So 2 must equal 8 lambda. So lambda must equal a quarter. And if lambda equals a quarter, then mu equals, let's have a look at that. 3 mu is 2 lambdas, so 3 mu would be a half, so 1 mu would be a sixth. There we go, so mu is a sixth. Now the question is, find the ratio OC to CE. Well, we started off in blue saying that OC is going to be equal to mu OE. So now I know that OC is equal to a sixth of OE. So the ratio O to C, C to E, O to C and C to E must be a ratio of 1 to 5. And that's my solution for that question. Question 14, done. And look at that, it was a question 24. These are tough questions on your IGCSE paper. Question 15. Right, we've got a trapezium, and we're given some vectors here. Best we write those onto the diagram. We're told that O to X is the vector A, and we're told that X to Y is the vector B, and we're told that O to Z is the vector 3B. Okay, it's 3 times xy, right. M is the midpoint of OX, right, so I'm going to write a half and a half. Done that, done that, done that, done that. N is the point on, so N is the point such that M, N, Z and O, N, Y are straight lines. Aha, N lies on 2 straight lines. We know where this question is going. Given that ON to OY is the vector lambda to 1, find the value of lambda. Basically, it's asking me, isn't it, to find that ratio. Okay, so let's do it in a normal way, shall we? We have got this point N, haven't we? And we know it lies on the line OY. So let's start off by saying that ON is some fraction of OY, we don't know what. Okay, and we'll use that to write an expression for the vector ON. Now, let's also bear in mind that N apparently lies on the line MZ. We don't know how far away along, but let's commit now to stating that Mn is sum of the way along. Now I can't use lambda because it's already been used, so I use alpha. Is sum of the way along Mz. And we're going to use that to construct a different expression for the vector On. So when we're doing this green one, we'll go from O to M, and then from M to N. Okay, let's go back to blue. Right, we have said that On is a fraction of Oy. Mu of Oy. Now what's O to Y? O to Y, oh, that's just A plus B. Look at that. So On is mu A plus mu B. All right, back to green. In the green one, we're going to write an expression for On using this route instead. So we've got On is O to M, which is a half of Ox. Okay, and then we've got some fraction of Mz. So a half of Ox, that's a half of A, plus a fraction of Mz. Now go from M to Z. Okay, well that's going to be minus a half A plus 3B. So let's simplify this. A half A minus a half alpha A plus 3 alpha B. So let's pull out the A, because I know I'm going to want the coefficient of A here. Okay, I've got two expressions for the same vector. So I know that the coefficients of the A's are going to be equal, and I know that the coefficients of the B's are going to be equal. And I can use those two facts to write a pair of simultaneous equations. So from the coefficients of the A's, I'm going to say that mu, the coefficient of the A on the left, equals a half minus a half alpha. And the coefficients of the B's will give me mu equals 3 alpha. Okay, I've got to solve those black equations simultaneously. So I'm just going to say that 3 alpha from the bottom equation equals a half minus a half alpha. Multiplying by 2, 6 alpha equals 1 minus alpha. 7 alpha equals 1. Alpha is a 7th. Okay. Right. So if alpha is a 7th, then mu is 3 times that, isn't it? So mu is 3 sevenths. Good. Right. That means that On is 3 sevenths of Oy. Okay, which means that if I went from O all the way to Y, then N is going to appear 3 sevenths of the way along, 3 and 4. So that's how it looks. Now, it wants me to address this problem here, doesn't it? So it has said On to Oy, and it tells me that that equals lambda to 1. It wants me to find lambda. So let's look at this diagram here. On to Oy, well, On is 3, to Oy, which is the whole line, 7. But it wants it in the form lambda to 1, doesn't it? So I'll need to divide this 7 by 7. So I'll need to divide the 3 by 7 as well. So I'll get 3 sevenths to 1. So what is lambda? Lambda is equal to 3 sevenths. That is that question, question 15, done. Question 16. Right. OACB is a trapezium. Yes, it is. OA is 2A, that's marked. OB is also marked. AC is also marked. And the diagonals cross at a point P, intersect at a point P. So we've got the point P, which lies upon OC. So we can use that to set up an expression for OP. And also the point P lies upon AB. So we can use that to set up an expression for OP. All right, let's do the red one first, shall we? Let's say that OP is a certain fraction of OC. I don't know what fraction, I don't know how far along it lies, so we'll say mu of OC. We can use that one in a second. In blue, we could also say that AP is a certain fraction along, AP is a certain fraction of AB. I don't know what fraction, let's call it lambda AB. And we'll use this to set up an alternative expression for OP, one that uses AP. So maybe OP is OA plus AP. Okay, so now I've got the means of setting up two different expressions for OP, one in red and one in blue. Let's go to the red. So OP is mu of OC. Now what is OC? O to C is going to be OA, which is 2A, plus AC. There you go. So that is 2 mu A plus 3 mu B. There's an expression for OP based upon the fact that P lies on the red line. Now let's go blue. We've got OP is OA plus lambda plus AP. Well, OA plus, well, AP is lambda AB, isn't it? So OA, well, that's 2A, plus lambda. Now AB, A to B, that's minus 2A plus 5B. Great, equals 2A plus, let's multiply that out, minus 2 lambda A plus 5 lambda B. Right, that is 2A minus 2 lambda A plus 5 lambda B. Let's take A out to give us the coefficient of A plus 5 lambda B. I think I'm almost there. So I've got two alternative expressions for OP. And because they're both, those alternative expressions give me the vector OP, I know that the coefficients on the A's must be equal to each other. And I know the coefficients on the B's must be equal to each other. So I can write my simultaneous equations. 2 mu equals 2 minus 2 lambda. And 3 mu equals 5 lambda. Brilliant. Right, let's see lots of different ways I can do this. I'm going to multiply this one by 3 and this one by 2, because then I'll get 6 mu in both equations. So if I multiply the top one by 3, I get 6 mu equals 6 minus 6 lambda. Bottom one by 2, 6 mu equals 10 lambda. So 10 lambda equals 6 minus 6 lambda. So 16 lambda equals 6. Lambda equals 6 over 16, 3/8. In which case, mu, let's have a look. Mu is equal to, well, mu is equal, 3 mu is equal to 5 lambda, isn't it? So to get mu, I'll take lambda, multiply it by 5 and divide by 3. Leaves me with 5/8. Okay. So now, what do I know? I know that OP is, you remember it was 2 mu A plus 3 mu B, looking at this. Now I know what mu is. That's 10/8 of A plus 15/8 of B. Now I can simplify that. 10/8 of A, multiply, divide top and bottom by 2, that's 5/4 of A plus 15/8 of B. Don't know what I wrote there, 15/8 of B, I should say. Right, so there's my answer. 5/4 of A plus 15/8 of B. And that is, crikey, that was a question 26 on a paper, that one. Okay, so that must have been the last question on the paper, I'm guessing. And we have just finished question 60. Very well done if you've made it through to the end of this film, and I hope you feel much clearer now on how to tackle these vector questions. Certainly, as I ran through the film, I found I got a lot more fluent at using that method to find those ratios. So leave me a comment in the comments, leave me a question if you'd like to, tell me how you got on with this truly monster vector film. Okay, see you in the next film.